the values of the angles x, y and z. So in this diagram, first of all, let us focus on x. So what do you see? These are two intersecting lines which are intersecting at this point, and this 55 degree and x are vertically opposite angles. And we know that vertically opposite angles are always equal. Therefore, x will be equal to 55 degrees. Why? Because they are vertically opposite angles. So we found out value of x. Now let's focus on y. So if you only focus on x and y, you see that x and y form linear pair. That is, sum of x and y is equal to 180 degree. So whether you call it linear pair or you call it supplementary, so it would mean the same thing in a way, here at least. So x plus y is 180 degree. Now the value of x is 55 degrees plus y is equal to 180 degrees. Therefore, you can say that y is equal to 180 degrees minus 55 degrees, which is equal to 125 degrees. So this would be the value of y. So we found out y, we found out x. What would be z? Now again, z will be equal to y because z and y are vertically opposite angles. So z will be equal to y will be equal to 125 degrees because again these are vertically opposite angles. So you see, just keeping in mind the properties, you can actually find out unknown values of various angles. So this would be 55 degree, this would be 125 degree, this would again be 125 degrees. Question number 8. Find the values of the angles x, y and z. Okay, so here also let's make use of properties. So let us first focus on x. So when you look at this portion, you see that this is a straight line, right? So this one is a straight line. So what does that mean? That means that this entire angle would be 180 degrees. So we can say that 40 degree plus x plus 25 degree is equal to 180 degree because all these angles together form a straight line, and straight line is 180 degrees. Therefore, this can be written as 40 plus 25 is 65 degree plus x is equal to 180 degrees, or we can say that x is equal to 180 degree minus 65 degrees, which is equal to 115 degrees. So this would be the value of x. Now what about y? So x is only this much, and this part is x. So we found out x. Now let us focus on y and z. Now z is pretty simple to find because z and 40 degree, these are vertically opposite angles, because this line and this line, these are two intersecting lines. This is the point of intersection. So z and 40 degrees, they lie exactly opposite to each other. Therefore z is equal to 40 degrees because they form vertically opposite angles. So now what are we left with? We are left with y. Now when you look at y, you would see that y and z also form 180 degree because they also together form a linear pair. So we can say that y plus z is equal to 180 degrees because they form linear pair. Therefore, y plus 40 is equal to 180 degrees, or y is equal to 180 degrees minus 40 degrees, which is equal to 140 degrees. So this is how we could find out the values of x, which is 115 degree, y, which is 140 degree, and z, which is 40 degrees. Question number 9. In the adjoining figure, name the following pairs of angles. Obtuse vertically opposite angles. So vertically opposite angles means angles formed by intersecting lines lying opposite to each other. But these vertically opposite angles should be obtuse. That means their value should be greater than 90 degree. So here you see one pair of vertically opposite angles would be this, but are they obtuse? No, their value appear to be lesser than 90 degree. So they are not obtuse. So the other pair that we have is this and this. So here when you look at this angle, this is quite a large angle which is an obtuse angle, and at the same time they are lying opposite to each other. Therefore we can say that angle AOD and angle BOC, they form obtuse vertically opposite angles. Adjacent complementary angles, that means two angles which are located one after another and their sum is equal to 90 degrees. So this kind of angle is here. So when you look at this one, this is a 90 degree, right? But this 90 degree is formed by two angles, this angle and this angle, and moreover these two angles are also adjacent, lying one after another. They have a common vertex, they have a common side, arm, they do not have any common interior points. So angle AOB and angle AOE, they are adjacent complementary angles. Equal supplementary angles, that means two angles whose sum is 180 degree and the value of both the angles are also same. So this is very obvious, it is going to be 90 degrees. So when you look at this angle, this is 190 degree, this is another 90 degree. So these two angles together form 180 degrees, therefore they are supplementary. So the answer would be angle EOD and angle EOB. Unequal supplementary angles. So where do you see supplementary angles but they are not equal? So where else do you see a straight line? So we see a straight line here, right? AOC. So when you look at this AOC, this is a straight line, therefore this angle would be 180 degrees. Now this angle is again formed by two angles. One is this angle and the other one is this angle, and they are not equal. So this angle is greater than 90 degree and this angle is less than 90 degree. Therefore these two angles are unequal but they are supplementary. So the answer would be angle AOE and angle EOC. Adjacent angles that do not form a linear pair. So two such adjacent angles which do not form linear pair, that means the angle should be adjacent but their sum should not be equal to 180 degrees. So two such adjacent angles could be this angle and this angle. So when you look at their sum, they do not form either 90 degree or 180 degree, but they are located one after another. They have a common vertex, they have a common arm, they also do not have any common point, common interior point rather. Therefore, we can say that angle COD and angle DOE are adjacent angles that do not form a linear pair. About so many different types of angles, it is time to talk about types of lines. Now again here also we will not talk about individual lines, rather we will talk about pair of lines. So the two common types of lines that we will talk about are the parallel lines and the intersecting lines. Now what do you see on the screen? You see the railway track. Now if you have ever traveled by a train, then you would have, and if you have observed the railway lines, you would have seen that normally the railway lines, they run together, and in two lines they are always like running in such a way that the distance between the two lines remain the same throughout. So these type of lines would be called parallel lines. Whereas at certain places you will see that one line crosses over another line at a particular point. So these type of lines would be called the intersecting lines. So railway track is one such example where you get to see intersecting lines as well as parallel lines, at the same place. So now we are going to talk about these two types of lines in more detail. So let's start with parallel lines. So these are lines which do not meet and maintain the same distance between them. So when you have two lines like this, such that the distance between them remain the same. So the distance at this place and the distance at this place, they will remain the same, and the lines will continue to extend infinitely, and still the distance between the two lines will remain the same. So that means these two lines will never meet, because there will always be this particular distance between them. So they will neither meet nor will they appear to meet. So these lines are called parallel lines. Whereas when we talk about intersecting lines, these lines, they have a common point because they cross over each other at a particular point. And this point where they cross over each other, this point is called the point of intersection, because this is the point where they meet. Now, basically, you might have examples like this where you do not see two lines actually meeting. For example, these two lines. What will you tell? Are they parallel lines or they are intersecting lines? Because in this case, these two lines do not really have a common point. Whatever is shown on the screen, that shows that they do not have a common point. But does that mean that they are parallel lines? No, because they do not satisfy the condition for parallel lines. In order to be parallel lines, the distance between the two lines need to be same throughout. But here on one side the distance is this much, and on the other side the distance is decreasing. So what is this picture showing? This is showing that the two lines have not met yet, but they will meet soon. So if you kind of extrapolate these lines, they are going to meet at a point. So basically these type of lines will also fall under the category of intersecting lines. Only those lines where the distance between the two lines remain constant throughout, they will fall under parallel lines. So let us look at this example. This is also an example of intersecting lines where the two lines have a common point. So this is the point of intersection, and these two are the intersecting lines. Let us look at some interesting examples of parallel and intersecting lines. Let's think of this table. So where do you see parallel lines and where do you see intersecting lines? So in this case, when you look at these two sides of the table, what do you see? They represent parallel lines, because you see the distance between them is maintained the same, right? So had this table been tapered towards one end, in that case these two have not been parallel lines. But in this case, the distance between the two lines have been maintained the same. Therefore, we can say that these are parallel lines. Whereas when you look at this line and this line, they intersect at a point. They have a common point. So they represent intersecting lines. You look at any such example, whether you talk about an almirah where you can actually compare these shelves. So the shelves are arranged parallel to each other. You see there, the distance between them is maintained the same throughout. Whereas when you compare this side with this side, they are intersecting lines because they meet at a common point. You look at this stool. So when you look at the three legs of the stool, do you think that they are parallel? So now they are slightly slanted. So basically the distance between the two legs here and the distance between them here are different. So that is why these two lines do not represent parallel lines. They are also intersecting lines which are not intersecting right now, but they appear to meet. So they also fall under the category of intersecting lines. Similarly, you can look at a window pane, and there also you can see both parallel and intersecting lines.